Hello everyone, this is Dhruv Dikshit from VIT University Chennai, and today I am going to talk about K-means clustering. So I'll only teach the basics. So K-means clustering works on unlabeled dataset, that is unsupervised machine learning. That is, we don't need to label the. Suppose we have a table and there are different columns, then that becomes labeled dataset. So we don't have to label anything for using K-means clustering. So in k-means clustering, we will basically what we'll do is that we'll split a data set into different clusters, and the number of clusters, let's suppose they are k. So every observation, like every entry in the in the cluster, in each cluster is same, like similar to each other, and is different from the entries in the other clusters. So now, what is centroid? The centroid is the center of the cluster, and suppose the value of k is 5, then for each cluster we'll have one centroid or center. So how does it work? The first step is the initialization. So suppose k value is 2, then we choose two random points as clusters and centroids. Suppose the black dots, let's suppose they are the centroids, and the blue dots are the entries in the cluster. So now we'll go to the step 2, where we'll assign the points to their respective centroids. So as we can see, the blue points are assigned to their respective centroids. So now in step 3, the centroids will move to the mean of the points that are in the cluster presently. So as we can see, the blue dots are no sorry the black dot is going to the mean of the points that is shown by the arrow, and it is moving. So after this step, the some points of a cluster may move to some other cluster also. So as we can see that right now, we'll show you that in the next step. See, this point, the blue point in the bottom, has moved from cluster 2 to cluster 1 when the centroid of cluster 1 moved down. So what can we use k-means for? First of all, if there is any grouping we have to do, suppose customer complaints or questions that are of similar type, and similar type of phone calls, and food preferences, anything that can be grouped together, k-means clustering can be used for that. And also it can also be used for finding anomalies in security and fraud, because the cluster will contain the entry which are similar, but if there is some anomaly like in the security or in fraud, then we can easily find out using k-means clustering. So what do k-mean clustering take as inputs? First of all, it is basically the z-score. It is computed using the mean value and the standard deviation by the formula shown, that are scaled numerical values, x minus mu upon standard deviation. Mu is mean, and sigma is standard deviation. So what are the outputs of k-means clustering? There are only two outputs, that is a set of labels for every observation, that is for every entry we get a label for that using the clusters, and also a centroid for each cluster, that is the number of centroids is equal to k, that I showed you in the previous slides. So how can we know whether a clustering model is better or worse than the other? This question is actually based on finding the value of k. So we can find the value of k and compute it using three types, and the best type is using k means plus plus. That is, I'll share the link in the description below. And how can k-means clustering fail? So k-means clustering is obviously subjected to local minima, because we have to choose the centroids based on the different observations or entries in different clusters. So if the local minima is not at par, or it is not that useful, then the centroids will be not that accurate, and our k-means clustering will fail. So Thank you very much. And these were the basics for K-means clustering. And I would like to thank Professor Premlata M from VIT University Chennai for giving me this opportunity to teach you all the basics of K-means clustering. Thank you.